Make it fit the first time. Stop using interchange formats. According to the Aberdeen Group, a provider of fact-based business intelligence research, 86% of best-in-class organizations meet launch dates. One of the major factors is to have the layout engineers access to the mechanical tools and data. Best-in-class organizations are 35% more likely to focus on multiple engineering design domains. The fact is, collaboration is key to time-to-market success. But how do we solve these issues today? We have very different design domains with unique design flows, practices, and data sets. We use the classic DXF files, IDF, IDX, IGIS files to pass the data back and forth. And any time you deal with a process flow that has interchange file formats, you have data loss, translation issues, and you are left to manually massage the data in order for the other design domain to accurately use it. We play the waiting game with serial design flows, and ultimately we have to redesign and respin board after board because it just does not fit in the box or the assembly. Take this into account that the cost of one physical prototype on a moderately complex PCB is nearly $9,000. Tell me there's a better way to do this. We need a true cross-domain co-design environment. A flow that takes the individual interchange file formats in the email exchanges that we do back and forth into a central repository, a single source of truth, where each design team can work in their native environment, but really work with a single data set, the way they want to work with that data set. And all that rich change history of exactly what's been happening throughout that design process is built into their design tools. We need a single source of truth, centralized and collaborative, that is correct and ensures data integrity, and is easy to access and easy to use. The greatest challenge for successful products today lies in the design process. Designers need tools that help them make the most of modern technologies, successfully manage projects, and deliver connected, intelligent products. Altium creates these tools. The heart and soul of technology today is PCB. We at Altium believe that if you can design it, you can change the world. Now, what does this mean for you? Well, we need dynamic fit checks in the 3D area. We need all of the board data on all design domains, whether that be copper, silk, holes, components, keepouts, boards, whatever that is. We need 3D mechanical DRC with the PCB. We need real-time commenting and functionality history flows, a single source of truth, as I said, and we need a true ECAD to MCAD co-design environment. Let me show you how. Now, as you can see, I'm automatically in the native 3D PCB environment just by hitting 3 on my keyboard when I'm in that standard 2D mode. What this allows me to do is place and route and have the full DRC capabilities right within my PCB environment. X, Y, and Z axis checking for all of my components. So now I can see those components I previously placed underneath there actually fit underneath that screen, but now my C20, it doesn't quite fit, and I'm going to need to go ahead and adjust that, move that to avoid that collision. Now I don't get rejects back to say, hey, we can't assemble this quite right. Although it worked electrically, it didn't work in terms of a fit. Right within this PCB environment, we also have the capability to view all data types, all PCB data types in this 3D environment. Copper, traces, via barrels, pad barrels, even flex circuitry within there as well. We can see all of that stuff simply by going to a single layer mode within that environment, Shift S. We will need to export that data out to some other format, just like we can for STEP, DXF, DWG, IDF, IDX files. We can also export out a parasolid format. What the Parasolid format affords us is the ability to export not only the component data, the board outline, the mounting holes, but full copper as well. So all the outside and internal copper layers we can go ahead and export. So we can import that Parasolid format into our mechanical tool of choice, in this particular case, SolidWorks. And now, as you can see, within this SolidWorks environment, we can go ahead and take a look at this board, see all of our components, and even reference those components in other areas, maybe in enterprise EPDM or even just a simple folder format. Now, if we were to view this in a wireframe format, we can actually see, document, manifest all of that copper data, that internal, nice, rich copper data with all the material information on there, even do a formal finite element analysis or thermal analysis of this printed circuit board within that entire system using that Parasolid format. Back in the PCB editor and Altium Designer, we can also go ahead and place in the 3D body, the clamshell, the assembly, the enclosure of where this printed circuit board resides. And whether you're getting this from some other system out there, your mechanical engineer gave this to you, maybe a third party get this to you, I can import this into my PCB and actually place and route around my mechanical considerations. Now look at this, we can go ahead and lock it to a particular point and it folds up directly within that environment. We have a true fold state of all of my rigid flex design, in which this actually is. It fits within here, we get no green errors, and we get a good fit check of everything. Everything is beautiful. And then we can go ahead and unfold this as well. Unfold this in the stack so we can see that fold state or even the assembly fold state within this. Now, we do want to interface on a co-design or collaborative way with our mechanical engineering teams. And what that actually means is that I need a way to go ahead and give that data over to the SolidWorks guy using our default extension within the tool. So now we can go ahead, initially check in, put my comments in there, and push that in using a centralized database, a single source of truth for all of this data. Now, as you can see, it's importing into the SolidWorks environment. It's actually rendering the assemblies, bringing in all the individual solid parts for all of my components, and viewing the full assembly in here. So now we are truly sharing the same data. No more relying on emails, no more reliant on, hey, did you get this part? Did you get that DXF? Did you get that step file? It's all one data source. And now I can make a change in any single one of the editors. For instance, in this particular case, the mechanical in SolidWorks. So now I can go ahead and expand that board outline out, expand the board outline there, apply that, simply push the release or the collaborative button there. So the Altium Designer collaboration, push that right over, put in my comments, and post that. And you get a nice, rich history of exactly who's been doing what at what time. Going back to Altium Designer as the electrical engineer, we can actually pull and instantly see that data and say, oh, look, there's been these changes made. And now I can call up in real time to the mechanical engineer and say, what are you doing? Or, yep, that makes sense, and apply those changes in real time. Reject those changes, even push those changes right back to say, you know what, this board outline did work. As you can see, we need something that helps us make it fit the first time. We need dynamic 3D checks within that PCB environment. We need all of the board data at every single domain, design domain, copper, silk, holes, components, keepouts, whatever they are. We need real-time commenting. We need a single source of truth for all of this data. We need an ability to do all this all at once.